Hi, it's Mrs. Green. So this lesson is going to be on, we're continuing studying volume. We have two new shapes to consider today, pyramids and cones. And remember, we've talked about this a little bit in class. Actually, not a little bit, quite a bit. We've got different shapes of pyramids. The classic pyramid is a square bottom, but you can have a triangular pyramid, which would have a triangle on the bottom. Or this is a 5 pentagonal pyramid. And then we're also going to talk about cones, because cones and pyramids are related. You can see their similarities. They've both got a vertex at the top, so they don't have two bases. They are one base figures, one base, and then they come to a point. And because of that, their volume calculations are similar, so this will be somewhat nice. We don't have to memorize two complete new concepts, just one. So first I want you to, forgot to have you write down your prior knowledge. So I know you have some prior knowledge of volume, because we did volumes of cylinders, and prisms in the last lesson. And the cylinder is very similar to the cone, and the prism is very similar to the pyramid. So this is a natural next step. So you have some idea of what volume is. Now we're continuing that concept with different shapes. So the first one let's look at is a cone, and I want you to notice that in this case, let's assume the cylinder and the cone have the same base, so they both have the circle, and that they have the same radius, and that they're the same height. And if that's the case, then the volume, if you imagine the cone or the cylinder being the base, if you take the top off, throw it away, and you squeeze the sides in, it could become a cone. So the volume is going to be a fraction of the volume of the cone is going to be a fraction of the volume of the cylinder, and that fraction is 1/3. And you might think, that's it. How do they know it's 1/3? Well, they've proved it. And it seems like it maybe would be 1/2, but it's not. It's even less than that. It's only 1/3, and I think of it as kind of the cone takes up about 1/3 of the space, because then you've got, excuse me, some area over there and some volume over here. So you're going to have to figure out a way to memorize that it's 1/3 the volume of a cylinder. And if you already know the volume of a cylinder is base area times height, or pi r squared times height, then you can easily memorize the volume of a cone. To put a 1/3 in front of all that, and off you go. There we go. So you just need to write that down in symbols and in words. Then let's talk about a prism and a pyramid. So a similar relationship exists between a pyramid and a prism. If you take, I'm going to replace width and length with base and height, because that's the way we talk about it now that we are moving on to geometry in middle school. Width and length was really more of an elementary school concept. It's not wrong, but you'll very, very often see base and height, so you need to understand that language. Now, the confusing thing, again, because now we have two heights. We have height, and that's maybe why people are labeling it with width and length, but you have to understand there's a height of the base, and then there's a height of the prism. And they both have h, so that is confusing. So this is the height of the prism, which is the distance between the bases, and then somewhere on the base there's a height as well. But it depends on the shape. And if it was a triangle, it makes sense when there's a rectangle to use width and length, but you could have a triangular pyramid, and then you don't have width and length, you have base and height. So it's more proper to use base and height for your two dimensions of the base. So we've got height being used twice, and the word base being used twice. Again, it's confusing, but you have to figure out a way to keep those straight. I do it using capital B and small b for base area. So we have, so the volume formula is this one that I'm using for prism. And then we have a convenient second formula for pyramid, which is 1/3 the base of the pyramid, the area of the base of the pyramid, times the height of the pyramid. And when you translate that, the volume of the prism, the bigger figure, the bigger 3D figure, is 3 times more than the volume of a pyramid that has the same, that starts out with the same base and is the same height, and then just goes to a point at the top instead of having a second base at the top. And again, you can kind of see if you were to draw in a pyramid that you've got 1, 2, 3 sections. So 1/3 does make sense. Okay, so let's look at some example problems. Oh, one more thing I want to bring up. In a pyramid, the height is not, it's not the slanty line here. Well, let me make it a different color, green. It's not the slant height. There is a name for this slant. It's usually a T or an S, and it's called slant height. That's not the height that we're using. That would be used if we were calculating the surface area of a pyramid, which we are not doing. You want, if you were to drop a weight from the vertex in the pyramid straight down so that it's perpendicular to the ground or to the base, and we know height always has to be perpendicular, that would be your height. So it's from the center down is your H, not the edge, not the slant height. Okay, so let's look at some examples. So example 1 is we want to calculate volume of this pyramid that's pictured here. So I know my formula for volume of a pyramid is 1/3 base area times height. Okay, I'm going to assume this is a square pyramid. Let me look in the book. Yeah, they tell you in the they tell you in words, and I didn't take a picture of the words. I just took a picture of the shape. So let me mark this so that it's perfectly clear that that is a square base. Otherwise, we don't know how to calculate the area of the base. But since we know that all of those sides are 12, I'm going to do a side calculation. Base area equals 12 times 12. Base area equals 144 centimeters squared. Now I'm going to come over to my volume calculation and substitute my capital B, 144. And I'm going to go back to my picture. And they've drawn a nice height. This indicates that they're dropping a weight down from the center. If they were to drop that down into the center, it's perpendicular to the bottom, the ground, and it's 25 centimeters. So you might see a picture like this where next to the picture it gives you height, or sometimes they draw it inside. So I've substituted for H, 25. Now I can calculate. This is a good time to use a calculator. I think 144 is divisible by 3, and then you can do the multiplication. So when I did that, I got 1,200, and my units are centimeters, so that's going to be centimeters cubed. Volume was always centimeters cubed because I had centimeters squared for my base area, and I multiplied by centimeters again, by 25. And that's 3 times that I multiplied centimeters, so that's centimeters cubed. Next example is a cone. And again, let's see if I missed any information out of the book. It says 20 centimeters across the top. So, oops. So your diameter is 20 centimeters. That's pretty clear. And then the height, again, if you drop a weight from the top of the cone down, in this case it's going up, but down to the ground if it's turned over, that's the height. And then they're picturing it like this with a line to the side. So the height is 21. So remember, it's not the edge here. No, it's not that edge. All right, so my volume of a cone is 1/3 base area times height. 1/3 base area, since I have a circle, is pi r squared. If you don't want to write the capital B and you just go directly to the formula for a circle, that's fine. But I'm instructing, so I need to make sure you're understanding where I'm getting all of my numbers. So let's substitute for pi 3.14. I've rounded. I used the classic 3.14. My radius is going to be 1/2 my diameter, which is 20, so that's 10 centimeters. 10 squared, and then my height is 21. So now it's just a big old calculation. So I simplified a little bit just to have you follow what I'm doing. You should look before you, especially if you don't have a calculator, which I'm not using a calculator here. You can divide by 3 the 21, so that turns into a 7. I know 100 squared, 10 squared is 100, times 7 would be 700, and then I just did the multiplication. So 2198 centimeters cubed. Okay, example 3 is a triangular pyramid. They didn't have this in the book, so I made one up here. And so my base is the blue part, and my base, the base of the pyramid is the blue. And then it goes up to the vertex in red. And I'm going to drop down from the center vertex the height. So that's designed to be a perpendicular line coming down, perpendicular, and I'm going to label that 9. So I've got volume equals 1/3 base area times height. Volume equals, so 1/3. So my base area I'm going to do over here is, this is a base, this is a triangle. So my base is a triangle. Its area will be 1/2 base times height. Don't get your bases mixed up. This is base area. This is base of my triangle. 1/2, and my base and height have to be perpendicular. So 6 and 7 are the base and height of my base, my triangular base. So that's going to be 1/2 of 6 is 3, 21. So 21, what's the units? I don't have units marked. 21 units squared. And then that's going to be my base area. The height of my prism is my h that's in my volume formula, and that's 9. That's not the red edge. So let's say the red edge is 10. You don't use the 10. You use the 9, which is dropped down from the center, which would be smaller than that slanty edge. And so that's 9 times. So I can reduce this to 7 and get 63 units cubed for my volume of my triangular pyramid. If you have a they might give you a pyramid that's got some kind of, it's a hexagon, yeah, oh, that's supposed to look like a hexagon, yeah, some kind of polygon base, and then it's a pyramid, so it goes down to all of the, in this case, we haven't studied how to get the area of a hexagon. So what would happen is they would say, well, the base area of the hexagon is 50, and then they'd tell you the height. So they drop down a line from, again, you're not using the slant height, you're using height from the center. They would give that to you, so let's say that's 7. So you'd have 50, so volume equals base area, B times H, 50 times 7. So that's not a hard calculation if they've already given you the area of the base. And they'll do that if it's a polygon where we haven't studied the formula for that area. Anything beyond like anything beyond a quadrilateral. But if it's a trapezoid, you need to be, you know how to do the base for a trapezoid, parallelogram, rectangle, square, triangle, and circle. Okay, practice problems out of the red book for once. Let's see. So find the volume of the solid. You're told that in exercise 3, it's a square base, so 1 by 1. In exercise 4, they ask you to leave your answer in terms of pi. And in exercise 4 is a little hard to read. The radius is 1. That's a 1. And it just goes halfway, so it's the radius. So radius is 1. And you can leave your answer in terms of pi if you want to. We can talk about that in class. We haven't done that yet. And then exercise 2 is one of those cases where I told you it's a pentagon, so they give you the base area. Okay, that's it. So don't forget to do your summary. Signing off.